I want to show you two photographs, and I want you to make a guess. The screen is going to split down the middle. On the left, a tangle of fine purple threads, knots where the threads bunch together, and long, quiet gaps where almost nothing runs. On the right, the same thing, more or less. Threads, knots, gaps. Two webs of stuff hanging there in the dark. So, which is which? Take a second. Left or right? Brain or cosmos? 3, 2, 1. The left one is the brain. The right one is the universe. And if you got it wrong, if you sat there genuinely unsure which of those two pictures was a crumb of a mouse and which was the entire observable cosmos, I want you to sit with how strange that is for just a moment, because that confusion is the whole reason we're here. Now, maybe you guessed right. Maybe there was some tiny tell, a grain in one, a glow in the other. Fine, but look at them again anyway, because getting it right isn't the interesting part. The interesting part is that the question was hard. These two things, one of them a wet lump you could hold in your palm, the other a structure so vast that light itself takes ages just to cross a single thread of it. These two things are built out of the same grammar. Hubs, cables, voids. The same shape, drawn at two sizes so far apart that there's almost no honest way to say it out loud. How far apart? The brain side and the cosmos side are separated by about 27 orders of magnitude. That's a 1 with 27 zeros after it. If a single neuron were blown up to the size of a grain of sand, the cosmic web at the same zoom would be, well, there's no kitchen table object big enough. You'd run out of universe. And here's the thing that turned this from a pretty picture into an actual problem. In 2020, two scientists who had no business working together sat down and made the comparison rigorous. One was Franco Vatsa, an astrophysicist at the University of Bologna who runs simulations of how the cosmic web forms. The other was Alberto Folletti, a neurosurgeon at the University of Verona, a man who spends his days inside actual human heads. Vatsa brought the cosmos, Folletti brought the brain. They published the result in a journal called Frontiers in Physics, and they gave it the driest title imaginable: The Quantitative Comparison Between the Neuronal Network and the Cosmic Web. Quantitative. That's the word that should make the hair on your arms stand up. Not they sort of look alike. They measured. They took something called the clustering coefficient, basically a number for how cliquey a network is, how much your neighbors tend to be each other's neighbors too. And they found that the brain and the cosmic web sit in almost exactly the same range, both around 0.1 to 0.4. Both wildly more organized than a random scatter would ever be. If you'd thrown the same number of dots down at random and wired them up by chance, the clickiness would be 1,000 times smaller. These two networks are not random. They are both built, and they are built to the same spec. I have to be honest with you, because honesty is the only thing that's going to make this whole journey worth your while. There's a caveat buried in that paper, and I'm going to hand it to you straight rather than hide it, because everything we do from here depends on me not cheating you. The brain side of that comparison used the physical spacing of the neurons, how close they sit to each other, not the true long-range wiring of which neuron actually talks to which. So this is a resemblance of shape, of statistics, of topology. It is not yet proof that they are the same kind of thing. Hold that. We are going to keep it honest the whole way down. But even with the caveat, the coincidences keep stacking, and they get weirder. Vatsa and Folletti worked out roughly how much information it would take to describe the structure of the cosmic web, every filament, every node, the whole woven thing. and the number they got was about 4.3 petabytes. Now, petabytes is one of those words that just slides off. Let me cash it in. 4.3 petabytes is, give or take, the amount of memory people estimate the human brain can hold. The cosmos's blueprint and your skull come out to roughly the same file size. And the lovely thing is that the paper doesn't oversell it for a second. That 4.3 petabytes is a measure of how much information the structure encodes, not a hard drive the universe plugs in and uses. And the authors more or less shrug at the whole resemblance and say, in so many words, this might just be a coincidence. We don't actually know. And then there's the filler. Your brain is about 3/4 water, a passive, sloshing medium that the real action just happens to swim in. The cosmos? Depending on which slice you take, somewhere around 2/3 to 3/4 of it is dark energy, this strange pressure that does nothing but sit there in the background pushing space apart. The old textbooks said 73%. The better modern number from the Planck satellite is closer to 68, and I'd rather give you the right one than the tidy one. In both the brain and the cosmos, most of the thing is just filler. The part that does the actual work, the threads, the wiring, the structure that carries the signal, that's the slim minority. Maybe a fifth, maybe a quarter. The rest is padding. So now you've got it. 2 networks, same clickiness, same rough information budget, same lopsided ratio of filler to wiring. Built at scales so far apart, there's no word for the gap. And right about now, there's a skeptic in the back of your head clearing his throat. I know him well. He's the same little man who rolls his eyes when I buy a lottery ticket, who mutters, "You know the odds, you fool," while I scratch the silver off anyway. And right now, he's standing up and shouting one word at me: pareidolia. The fancy name for the brain's habit of seeing faces in burnt toast and galloping horses in the clouds. He's saying, you're a pattern-matching ape. You found 2 splotches that rhyme, and you've talked yourself into a miracle. Sit down. And honestly, he's usually right. He's right about the toast. But here's why he doesn't get to win this time. Pareidolia is your eyes flattering you. This wasn't eyes. This was mathematicians, the least romantic people who have ever lived. People who would happily tell you your wedding photo is statistically unremarkable, and they ran the numbers and got punched in the face by them. A clustering coefficient doesn't see faces in clouds. A petabyte count doesn't get sentimental. The pattern survived the one test pareidolia always fails. It survived being measured. So the toast objection is off the table, which leaves the door open to a much bigger, much more uncomfortable question. And it's this: if the universe doesn't just look like a brain, if it clusters like one, stores information like one, is wired in the same lopsided proportions as one, then maybe the resemblance isn't only skin deep. Maybe it goes all the way down. And if a thing is built like a brain, does it also do what a brain does? Does the universe think? Now, let me get ahead of you, because I can feel you tensing up. I am not about to sell you crystals. I am not going to tell you to manifest a parking spot or align your chakras with the galactic core. I'll lay my cards on the table right now. I am a committed agnostic. I don't know if there's a God. I don't know if there's a mind out there, and I am deeply suspicious of anyone who tells you they do. What I'm going to do instead is something much more fun and much more rigorous. I'm going to take the most hard-nosed, materialist, equation-driven science we have, the stuff that built your phone and your microwave, and I'm going to follow it honestly, all the way to the bottom, refusing to flinch. And I'm going to keep handing the microphone to that skeptic in the back over and over and let him take his best shot at every step. If the dead, mechanical universe survives that, great. If it doesn't, well, that's the trip. So let me sketch where we're going. And I'm only going to show you the questions, not the answers, because the answers are the whole point, and I'm not spoiling them. We're going to climb all the way inside an atom and ask whether the tiniest bits of matter could, in some faint way, experience anything at all, and then turn that into a brutal engineering problem, because light is agonizingly slow on cosmic scales. So how many millions of years would a universe need just to have one thought? And along the way, I'm going to walk you up to the single most frightening idea in modern physics, a thing called the Boltzmann brain, and make you doubt whether you are even real. Until we're standing in front of the question underneath all the others. If the universe is thinking, is it awake? And if it is, could the one slow thought it's having right now be you? Let me leave you with one image before we start climbing to fix the stakes. Imagine you're the first human on Mars. You're walking across this dead red desert, billions of miles from any toy shop that has ever existed. And you look down, and half buried in the dust is a Lego brick. A standard one. 4 studs by 2. You pick it up, you brush it off, and on a whim, when you get home, you press it down onto the set you had as a child. And it snaps. Perfect fit. The studs line up to the micron. Now, there are only 2 explanations for that. Either it is the single most outrageous coincidence in the history of everything, or somewhere out there, something was using the same mold. Those 2 photos, the brain and the cosmos, that Lego brick is exactly the problem we're holding. So let's go find out which it is. Before we climb in, one small thing, and then I'll leave you alone with the physics. I've just asked you to take a blind bet, to stare at 2 photographs and wager which one was a universe. That is, more or less, the entire personality of this channel. A quiet voice handing you strange wagers and then turning over the cards one slow card at a time. Maybe you'd like a new strange wager every few nights for whenever your brain is finally off the leash. If so, the subscribe button is right there, and it costs you nothing but a tap. I will fully understand if my inner skeptic is already muttering that nobody taps the button. He's wrong about the lottery, and he's probably wrong about this too. So, back to the Lego brick on Mars, and the question of who keeps using the same mold. So let's start with the brick, and ask the obvious follow-up. If the brain and the cosmos really were stamped from the same mold, who made the mold? Because the strangest part isn't even that they match. The strangest part is how they were made. Think about how a brain gets built. It takes about 9 months. It happens in the warm dark of a womb, suspended in fluid, following a recipe written in DNA, a recipe refined over hundreds of millions of years for one purpose: to keep a fragile animal alive long enough to make another one. It is wet, it is fast, it is biological, it is desperate. Now think about how the cosmic web got built. It took 13.8 billion years. It happened in the freezing near emptiness of space, a hair above absolute zero, with no recipe, no DNA, no purpose anyone has ever found. Just gravity, patiently, blindly, pulling matter around for longer than you can hold in your head. Picture 2 builders who have never met and never will. One lives in Antarctica and has only ever worked in ice. The other lives in the deep desert and has only ever worked in sand. Different materials, different climates, different tools, no contact, no shared plans. And one morning, you fly over both of their workshops, and you find that they have each, independently, built the exact same castle. Not similar. Identical. Same towers, same gates, same impossible little detail on the 3rd turret. you would not call that a coincidence. You would start looking very hard for the rule they were both obeying without knowing it. That's where we are. Same castle, opposite builders. And the rule they were both obeying turns out to have a name. It is not, I'm sorry to report, a god with a white beard sketching galaxies onto a drafting table. Remember, I'm an agnostic. I'm not smuggling one in through the back. The rule is something physicists call the principle of least action. And the homeliest way I can put it is this: nature is cheap. Nature is the stingiest contractor who has ever lived. Next to nature, Scrooge is a soft touch, a philanthropist, a man who tips generously. Whenever nature has a job to do, get this light from here to there, settle this matter into some arrangement, it finds the single laziest, most economical path, and it takes that one every time. And here's the consequence that matters. When you've got a contractor that lazy and you hand him a problem, connect a lot of stuff across a lot of space efficiently on a budget, he is going to arrive at one best answer. A network of dense hubs joined by thin threads with big empty gaps in between. That's the cheapest way to wire up a lot of nodes. So when the universe needed to arrange its galaxies, and when biology needed to arrange your neurons, they both went to the same stingy contractor, and he handed them both the same blueprint, and he just scaled the ruler up by 27 orders of magnitude and copy-pasted. He didn't redesign for the bigger job. Why would he? Redesigning costs more. He's cheap. And the early universe gave him the perfect raw material to do it. Right after the Big Bang, the cosmos was almost perfectly smooth, a vast, even soup, like a pot of porridge stirred until there's not a single lump left. Almost. There were the faintest ripples, places where the soup was a hair denser than its neighbors. And gravity, which is itself a kind of greedy thing, always pulling the rich toward the rich, gravity grabbed those denser spots and pulled matter toward them. And as they got denser, they pulled harder. And over billions of years, that smooth porridge got drawn out into long, thin threads, the cosmic filaments, with great knots where the threads cross. And at those knots, clusters of galaxies. Hubs and cables and voids. The blueprint. And notice the proportion has come back around. The structure that does the work, the threads, the wiring, is the minority. The rest is filler. That 2/3 or so of dark energy doing nothing but holding the spaces open. The same lopsided ratio you've got in your own head. A little bit of wiring swimming in a lot of water. The stingy contractor used the same recipe twice. So now we have a thing that is wired like a brain, proportioned like a brain, built from the cheapest brain blueprint there is. Which means it's time for the question that's been waiting. We've got the wiring. We've got the architecture. But who flips the switch? A circuit board is not a mind. A blueprint of neurons is not a thought. What is the thing that turns wiring into experience? And could a universe ever have it? To even ask that question properly, we have to go back 400 years to the man who, more than anyone, built the dead universe we're trying to wake up. And taste the irony of it. He did it on purpose, and it was the best decision anyone ever made. And it is also why we're stuck. The year is 1623. The man is Galileo, and he is writing a book called The Assayer. And in it, he does something so quietly radical that we're still living inside the consequences. He takes the world, the whole rich, warm, loud, colored, smelly world, and he cuts it cleanly in half. On one side of the cut, he puts the things you can measure: size, shape, number, position, motion, how big, how many, how fast, where. These, says Galileo, are real, They're genuinely out there in the objects themselves, whether or not anyone's looking. On the other side of the cut, he puts everything else: color, taste, smell, sound, warmth, the red of the wine, the sweetness of the fruit, the music. And about all of that, he says something that should stop you cold. He says these are not really in the objects at all. They are, in his words, no more than names. They live only in the creature doing the perceiving. Take away the living, sensing thing, he says, and all of it, every color, every flavor, every sound, is wiped away and annihilated. Read that again slowly. Galileo just told you that the redness of red isn't in the rose. It's in you. The rose is just particles of a certain size and motion bouncing light of a certain wavelength. The red part, the part you actually experience, that's a private event happening inside your skull, and the universe out there is colorless. Let me hand you the scalpel so you can feel the cut yourself. Imagine the most exquisite dish a 3-star Michelin chef ever plated. The one that makes people close their eyes and go quiet at the first bite. Now, do science to it, Galileo style. First, fire the chef. His intentions aren't measurable. Into the bin. Then, pour the sauce into a beaker and write down what's actually objectively there. So many grams of warmed protein, a few chains of fat, water, 0.5% sodium chloride. And finally, switch off your own tongue and your own nose, because those are just your unreliable instruments. There. You now have a complete, objective, measurable description of the dish. Every real property captured. And where did the deliciousness go? It's nowhere in the beaker. It was never in the food at all. By Galileo's cut, the flavor was only ever an event in you. And the moment you got rigorous, it vanished off the page. A quick, honest footnote, because I promised not to cheat you. The tidy labels for this, primary qualities for the measurable ones, secondary qualities for the felt ones, those came later from the philosopher John Locke in 1689. Galileo made the cut. Locke named the two piles. I don't want to put Locke's words in Galileo's mouth. Now, why on earth would anyone do this? Why throw out color and music and warmth? Because it worked spectacularly. By shoving all the messy, subjective, unmeasurable stuff into a private bin marked your brain's problem, not physics problem, Galileo cleared the runway. What was left? Pure quantity, pure measurement. You could do mathematics too. You could write equations. You could predict. Everything we have, every triumph of physics, from the orbit of the planets to the screen you're reading this on, sits on top of that one ruthless cut. He fired the messiness so the machine could fly. But look what's left behind on the runway. Look at what got swept into the bin. What got swept into the bin is experience itself. And the universe that's left, the one physics describes so perfectly, is, if you take it at its word, completely dead. It's a science of skeletons, a clockwork of particles, pushing and pulling each other in perfect, predictable mathematical silence, with nobody home. No color anywhere, no taste, no pain, just the bones of things, clicking. And there's a thought experiment that makes the strangeness of this land in your gut, and I'm afraid I have to do it to you. It comes from a living philosopher named David Chalmers, who in the mid-1990s gave the problem its modern name and its sharpest knife. Chalmers asks you to imagine a perfect copy of yourself. Atom for atom, identical. Same brain, same wiring, same everything. I pinch this copy, and it says, ow, and it pulls its hand back, and the right neurons fire, and it tells you, convincingly, that it's in pain. It behaves exactly as you would.
There is just one difference.
Inside, there is nothing. No actual feeling of pain. No redness, no warmth, no inner movie playing. The lights are all off. It processes the input, runs the program, outputs the scream, but there is no one in there for whom any of it is like anything. Chalmers calls this a philosophical zombie. Not the groaning, brain-eating kind from the movies. The opposite, really. This one is polite and functional and indistinguishable from you. It just isn't anybody. Picture it at kitchen scale. A house where the wiring is flawless. Every appliance hums. Every motion sensor should be tripping. Every switch works. The electricity is flowing perfectly through every circuit. And you walk through every room, and it is pitch black. Nobody turned on a single light. Nobody's home to need them. The machinery is perfect, and the house is empty. That's the philosophical zombie. That's the dead universe physics describes. Everything works, nobody's there. And now, the question has teeth, because here's what's so weird. You are not a zombie. You know you're not, with more certainty than you know anything else in the world, because there is something it is like to be you right now. There is a light on. You are having an experience of these words. So nature went to the trouble, somewhere, somehow, of installing the one feature that, by Galileo's accounting, physics says shouldn't need to exist at all. Why? Why is anybody home? Where did the light come from? Now, somebody clever always jumps in here with the word emergence and waves it like it settles things. Look, you don't need anything mystical. Wetness emerges from water. A single water molecule isn't wet. Wet is meaningless for one molecule, but get a few trillion of them sliding past each other and whoosh, wetness appears. A brand new property nobody put in on purpose. So, get enough neurons firing and whoosh, consciousness emerges. Same trick. Move along, nothing to see. And it sounds great until you look at it closely, and then it falls apart. And it's worth seeing exactly why, because this is the crack the whole rest of the night climbs through. Wetness is a behavior. It's a thing water does. It flows, it spreads, it beads. And every bit of that behavior you can, in principle, derive from the molecules. Their shape, their bonds, the way they slide. The wetness is fully accounted for by the parts. Nothing got added. But the smell of coffee? The actual experience of it? The warm, dark, what it's like of that smell? Try to derive that from sodium ions crossing a neuron's membrane. Go on. Write the equation where you put in ion moves across membrane on one side and the felt smell of coffee comes out the other. You can't. Nobody can. There is no step in the physics where the feeling shows up. To say it just emerges isn't an explanation. It's a place where someone wrote, and then a miracle occurs, and hoped you wouldn't notice. This is what Chalmers called the hard problem of consciousness, and it is the wall that the dead, mechanical universe slams into and cannot climb. So, materialism, the clean, powerful, equation-driven worldview that built everything, has a hole in its floor exactly where you are standing. And right at this moment, when the mainstream is stuck staring at the wall, a small group of serious people pick up a key that everyone had thrown away. The key is an idea with a frightening name, Panpsychism. And before you flinch, yes, it sounds like incense and wind chimes. It isn't. It's an idea that genuinely sober philosophers argue for in genuinely sober journals. And it goes like this. We've been assuming that the universe starts out dead, and that somewhere up the ladder of complexity, life and brains conjure consciousness out of dead stuff, and we just saw that nobody can explain how. So Panpsychism asks, what if we had the order backwards? What if consciousness was never conjured at all because it was there from the start? What if experience isn't a rare trophy that complex matter wins, but a basic property of matter itself, like mass or charge, present in some unimaginably faint and simple form all the way down to the smallest bits? This is not a new fringe whim, by the way. One of its great modern champions was Bertrand Russell, one of the most ferociously logical minds of the 20th century, a man who tried to rebuild all of mathematics from scratch. And in 1927, he laid out the wedge that makes the whole idea stand up. He pointed out something about physics that once you see it, you can't unsee. Physics, for all its power, only ever tells you what things do. It tells you an electron has mass, which is just to say it's hard to push. It tells you an electron has charge, which is just to say it shoves away other electrons. Behavior, behavior, behavior. Relations and pushes and pulls. But physics never once tells you what the electron is, what it's actually like on the inside to be that little knot of being. Physics describes the outside of everything and the inside of nothing. And Russell's heirs, like the philosopher Philip Goff today, ask the obvious, vertiginous question: what if the inside, the intrinsic nature physics is silent about, what if that is experience? Not thought, not feeling as you know it. Just the faintest possible glimmer of being something rather than nothing. Put it this way, your consciousness right now is like a vast, high-definition surround sound movie. Color and depth and feeling, all of it playing in 4K. An electron's experience, if it has one at all, would be a single pixel. One pixel with one setting, on or off. That's it. Almost nothing. But almost nothing is not nothing. And that gap is everything. Because if even one pixel of being is real at the bottom, then the universe was never dead. It was dim. And dim things can be turned up. I have to keep my promise, so let me be crystal clear about where we are. Panpsychism is not a finding. No experiment proved it. It is a serious, currently argued position held by a real but distinct minority of philosophers. It is one way to look at the hole in materialism's floor, a clever, honest, unproven way. I'm offering it to you as a lens, not a fact. Put it on, and let's see what the world looks like through it. And the second I say that, the skeptic is back, and this time, he's actually got a great point. Fine, suppose every electron has its one little pixel of being. So what? You are made of, what, 100 trillion of these things? If each one is a tiny dim mind, then you should be a deafening crowd of 100 trillion tiny dim minds all shouting over each other. A riot, a mob, total noise. Lock 100 million faintly conscious specks in one room, and you do not get a genius. You get a racket. So how do all those pixels become one smooth picture? How do a trillion little experiences add up to the single, unified, seamless you that is having one experience right now? That objection is so good, it has a name. It's called the combination problem, and it is the single hardest thing panpsychism has to answer. The philosopher William James pointed at it more than a century ago. And it's a real problem. I'm not going to wave it away. But the answer, when we finally get to it, is going to be one of the most beautiful turns in the whole story. Before we can reach it, though, we need to deal with a hidden assumption you've been carrying this whole time without noticing. The assumption that thinking even needs a brain at all. Because it doesn't. And the proof is crawling around under your garden. In 1881, an old man published his very last book. He'd go on to die the next spring. And the man was Charles Darwin. And the book, the final thing he chose to leave the world after revolutionizing all of biology, was about earthworms. It is a deeply strange and lovely book. Darwin became obsessed in his old age with the question of whether worms have anything you could call a mind. So he tested them in the most wonderfully eccentric ways. He shouted at them. He had his son play the bassoon at them, the deepest, loudest notes, and the worms ignored it completely. He set a pot of them on the piano and banged the keys, and then they reacted, but only to the vibration coming up through the soil, not the sound. From all this, he concluded carefully that worms are stone deaf. But then he watched them pull leaves into their burrows for the winter, and he found something that genuinely unsettled him. A worm, dragging a leaf down into its hole, almost always grabs it by the pointed tip, which is, in fact, the most efficient end to pull, the end that folds and slides into a narrow hole most easily. Now, that could just be blind instinct. So Darwin, being Darwin, gave them leaves they'd never encountered, from foreign plants, and even little triangles cut from paper. And the worms still mostly chose the efficient end. They were, somehow, responding to the shape of the thing, solving the problem fresh, not running a preloaded reflex. Darwin chose his words with enormous care. He wouldn't overclaim, and he wrote that the worms judged with a considerable degree of correctness and showed some degree of intelligence. A worm, with no brain to speak of, judging. And if a worm is too much brain for you, it does at least have a few nerve clusters, then let me introduce you to something with no brain whatsoever. No neurons, no nervous system at all, that solved a problem your city's transit planners would weep over. It's called a slime mold, Physarum polycephalum, if we're being formal. And if we're being honest, it looks like someone dropped a splat of bright yellow mustard on the pavement. That's it, a single-celled smear of living goo. No brain, no eyes, no central anything. And here is what Atsushi Taro, Toshiyuki Nakagaki, and their team in Hokkaido, Japan did with it in a study published in the journal Science in 2010. They took a map of Tokyo and the cities clustered around it, about 36 locations in all, and on each city they placed a flake of oat, because slime mold loves oats. Then they dropped the mold on Tokyo and they let it explore. And the mold spread out, groping blindly in every direction at once, a sprawling fan of yellow goo. And then it began to prune. The tubes that led nowhere useful, it let wither. The tubes that connected the oat cities efficiently, it thickened and fed. And after about a day, the network of living tubes it had built to connect those 36 points was about as efficient, as fault-tolerant, as well-balanced as the actual Tokyo rail system. The one that took human engineers decades of meetings and surveys and a fortune to design. A smear of yellow goo with no brain redrew one of the most sophisticated transit networks on Earth overnight by feel. And it wasn't a fluke of one weird study. A decade earlier, in 2000, the same kind of mold had already been filmed solving a maze, oozing through the corridors and then retracting itself down to the single shortest path between two snacks. I'll confess, this one humbles me personally. I once spent 20 minutes lost on a tangle of motorway ramps, one of those nightmare interchanges where the exits loop back over themselves like a dropped plate of spaghetti, circling the same junction 3 times while my phone gently judged me. And a brainless puddle of mustard solves the topology of Tokyo while it digests its breakfast. So here's where the slime mold leaves us, and it's a genuine shift. It doesn't have a plan. It has no little map in its head, because it has no head. The plan isn't inside it. The plan is its own body, reshaped, becomes the answer to the question. Thinking, it turns out, might not be a thing that happens in a brain. It might be a thing that happens whenever a network reshapes itself toward what matters. And that should make you look at the cosmic web very differently. Because the cosmic web is also a network, the biggest one there is. But to really earn that leap, we can't stay up here at the level of goo and worms. We have to go all the way down into the atoms, into the wiring of a single neuron, and ask whether matter, at the very bottom, could actually be running the kind of trick that builds a mind. For most of the last century, if you'd said there's quantum weirdness happening inside your warm, wet brain, and that's where consciousness comes from, you'd have been laughed out of the room. And for a good reason, which we'll get to. But two men said it anyway, and the pairing is so odd, it's almost a comedy act. The first is Roger Penrose, and this is not a crank. Penrose is one of the most celebrated mathematical physicists alive, a man who did foundational work on black holes alongside Stephen Hawking, who later won a Nobel Prize. Penrose had a hunch, a deep one, that human consciousness can do something no ordinary computer can do, that there's a spark in our thinking that isn't just calculation, and that to find it, you'd have to go below the ordinary machinery of the brain, down to where the laws get strange. Down to the quantum. The second man is the unlikely one. He's an anesthesiologist named Stuart Hameroff, a doctor who, for a living, makes people's consciousness switch off. And that gave him a question that haunts him to this day. When he gives you anesthetic gas, your consciousness goes out like a candle. Click, gone. And yet your brain's electrical activity is in many ways still chugging along. The machinery's still running. So what exactly did the gas switch off? Hameroff thought he knew where to look. Inside every one of your neurons, there are tiny hollow tubes called microtubules, for ages dismissed as boring scaffolding, the tent poles that just hold the cell's shape. Hameroff suspected they were something far stranger, the actual wiring of a quantum computer humming away inside each of your brain cells. A Nobel-winning mathematical physicist and a gas doctor forming a band. The styles could not be more mismatched. And together, they wrote a theory with a name that sounds like furniture assembly instructions: orchestrated objective reduction. ORCH-OR. The gist: inside those microtubules, particles sit in quantum superposition, that ghostly state where a thing is somehow both 0 and 1, here and there at once. And then, in a precise orchestrated instant, the superposition collapses down to one definite answer. And Penrose's idea is that each one of those collapses is a single flicker of raw proto-consciousness. Thousands of them a second. A strobe of tiny nows, and the stream of them is your mind. I need to be very honest about the status of this, because it's the most overreachable idea in the whole episode, and the skeptic in the back has been waiting years for this one. ORC-OR is not accepted by mainstream neuroscience. It has been criticized hard from the day it was born. And the killer objection came from a physicist named Max Tegmark in the year 2000, and it is devastatingly simple. The brain, Tegmark pointed out, is hot. It's wet. It's a chaotic, jostling, noisy place, a rainforest at noon, not a clean, cold laboratory. And quantum states are exquisitely fragile. The tiniest bump from the surrounding warmth makes them decohere, collapse, fall apart. Tegmark ran the numbers and found that any quantum state in a microtubule would survive for something like a tiny fraction of a fraction of a fraction of a second, vastly too short to matter for the millisecond rhythms of actual thought. Trying to keep a quantum computation alive in your brain, he was saying, is like trying to build a snowman in the mouth of an erupting volcano. It's gone before you start. So that should be the end of Penrose and Hammeroff. The band gets booed off the stage. Except, and this is the twist that keeps them in the conversation, over the last 2 decades, a brand new field grew up and showed that nature does, sometimes, in special places, pull off exactly the trick Tegmark said was impossible. It's called quantum biology, and it has one absolutely solid, beautiful crown jewel. And I want to lean on the strong evidence, not the shaky stuff. The crown jewel is a bird. A European robin, on its long migration, needs to read the Earth's magnetic field to know which way to fly. And the way it does it appears to be genuinely a quantum trick happening inside its eye. When blue light hits a special protein in the robin's retina, a molecule called cryptochrome, it knocks loose a pair of electrons whose quantum properties, their spins, are linked, entangled. And the delicate dance of those 2 entangled spins is sensitive to the Earth's magnetic field. It tilts the chemistry one way or the other, depending on which direction the bird is facing. A chemical compass running on entanglement in the warm, wet tissue of a living eye. And in 2021, a team published work in Nature showing that the cryptochrome taken from migratory robins really is magnetically sensitive in the lab, more so than the version from birds that don't migrate. This is real. This is peer-reviewed. Warm, wet, living biology is running a quantum trick. The volcano did not melt this particular snowman. Now, I have to draw the line carefully here, because this is exactly where an honest guide and a huckster part ways. The robin is solid. It proves quantum effects can survive in warm biology in a few special sheltered spots, long enough to do one small job. It does not prove OR. The defenders of OR argue that microtubules might be unusually quantum-friendly places, maybe even shielding their fragile states somehow. But that is a contested, unproven claim, and I am not going to tell you that experiments have shown microtubules protect quantum states long enough for consciousness, because they have not. What the robin gives us is permission to take the idea seriously, to say warm quantum tricks are real, so the door isn't slammed shut, and no more than that. Penrose and Hammeroff carry wonder here, not proof. The lens stays a lens. So hold it this way, which is fair to everyone. A quantum state in a living body is like a candle flame in a hurricane. Almost always, the wind of all that warm chaos snuffs it instantly. But it seems that in a few special places, behind a robin's eye, deep in the green machinery of a leaf, life has learned to cup a hand around the flame and keep it lit just long enough to do one useful thing. That's the real, defensible marvel. Whether your microtubules are one of those sheltered candles, that we don't know. But we no longer get to say it's impossible. And that crack of not impossible is all the next move needs. Because now, we can finally go back and answer the combination problem. Remember it? The objection that a trillion tiny minds should make a deafening mob, not a unified you. The way out is lovely. The mistake was imagining the brain as a telegraph, a billion little stations sending messages back and forth, shouting to be heard, which would indeed just be noise. But what if the brain isn't a telegraph at all? What if it's an orchestra? Think of a crowded market. 100 different voices, all yelling different things, complete chaos, pure noise. That's the mob the skeptic warned us about. Now imagine that, in a single instant, every one of those 100 voices opens its mouth and sings the exact same note, perfectly in tune, perfectly together. The noise doesn't get louder, it transforms. It becomes one clear sound, one chord, something that none of the voices was on its own. That's the idea. Quantum entanglement, The same spooky linking that runs the Robin's compass could, in principle, bind all the little quantum flickers across all your billions of microtubules into one unified, resonating whole. Not a billion minds passing notes. One mind, sung by a billion throats at once. And in this picture, that resonance is you. You are not a thing sitting inside your skull receiving signals. You are the standing wave, the chord, the one note that 100 billion neurons are singing together this very second. You are the quantum storm in the microtubules, and the reason you feel like one person, seamless and whole, rather than a riot of parts, is that you're not the parts. You're the song they make. Lens check, because I keep my word. That whole move, entanglement binding the brain into one conscious note, is the speculative OR picture, the thing Tegmark's objection still hangs over. I'm handing it to you as the most beautiful version of the answer, not as settled neuroscience. But hold on to the shape of it, many bound into one by entanglement, because we're about to take that exact shape and blow it up to the size of the universe. So, do me a favor and look up. If you can, picture the night sky, that whole spill of stars, the smear of the Milky Way. We've built a model of how a brain might work, wiring, a quantum trick that binds the parts into one resonating whole. And the cosmic web is wired the same way. So the obvious, audacious question is the universe running the same trick? Is it binding its parts into one vast resonance, one cosmic mind? And here, the skeptic doesn't even need to clear his throat, because the objection is enormous and obvious, and it's made of the most reliable thing in physics. Light is too slow. Let me show you how slow. Take our galaxy, the Milky Way, and call it the left hemisphere of this would-be cosmic brain. Now take our nearest large neighbor, the Andromeda Galaxy, the closest big spiral to us, and call it the right hemisphere. How far apart are these two hemispheres? About 2.5 million light years. Which means, if the left hemisphere wants to send a single thought to the right hemisphere, the cosmic equivalent of one neuron firing to the next, that signal, traveling at the absolute cosmic speed limit, the speed of light, takes 2.5 million years to arrive. And if the right hemisphere wants to reply, just to say, got it, that's another 2.5 million years back. One round trip. One, hello. Hello back. 5 million years. To feel how absurd that is, in the time it takes this cosmic brain to complete one back and forth between two of its own neurons, our ancestors could climb down from the trees, learn to walk upright, invent language, build the pyramids, split the atom, walk on the moon, go extinct, and be replaced by an entirely new civilization of, highly intelligent cockroaches who build their own pyramids. And the cosmic thought still wouldn't be finished. If your own nervous system ran that slow, you'd stub your toe on the furniture, and you'd feel the pain and scream, ow, roughly 40 years later. On the afternoon of your retirement. That is not thinking. That is geology. So that's it, right? The cosmic mind is dead on arrival, killed by the speed of light, the one law nobody breaks. Case closed. Go to sleep. Unless the universe knows a shortcut that doesn't have to walk the slow road through space at all. And there is a candidate for exactly such a shortcut, and it's the strangest thing in all of physics, and I have to handle it with total honesty because it's the moment where a dishonest version of this story would cheat you, and I won't. Go back to 1935. Einstein, yes, that Einstein, together with two colleagues, Podolsky and Rosen, points out something about quantum mechanics that he finds so absurd, he thinks it must mean the theory is broken. You can prepare two particles in a linked entangled state and then carry them light years apart, and they remain correlated. Measure one, and you instantly know something about the other, no matter how far away it is. Instantly, across any distance. Einstein hated this. Years later, in a 1947 letter, he gave it the name that stuck: spooky action at a distance. And the word entanglement itself we owe to Schrödinger that same strange year. It looks for all the world like a connection that ignores space entirely, exactly the shortcut a cosmic mind would need. But here is the catch, and this is the rung where the honest version of this story has to lose, on purpose, out loud, because if I skipped it, you should never trust me again. You cannot use entanglement to send a message. You can't. There's a theorem. It's called the no communication theorem, and it is rock solid, proven physics, not a guess. And it says that no matter what you do to your half of an entangled pair, you cannot make any usable information appear on the other half. If you measure your particle, your faraway partner's particle does not show any sign of what you did. On their end, the results look completely random. The correlation is real, but it's useless for sending signals. You only discover the correlation later, when the two of you compare notes over an ordinary, slower-than-light channel, a phone call, a letter, a beam of light crawling across the gap. You cannot text the lottery numbers to a friend in Andromeda. The universe forbids it. Einstein's spooky action is real, and it absolutely, definitely cannot carry a message faster than light. Relativity is safe. The skeptic wins this round, cleanly, and I'm tipping my hat to him. So, does that kill the cosmic mind after all? Here's the subtle, honest thread out. And notice, I'm not taking back what I just conceded. A message requires a sender and a receiver, and a signal that travels between them. But your brain doesn't work by sending itself messages. Your left hemisphere doesn't mail a letter to your right hemisphere and wait for the post. The unity of your mind isn't transmission, it's resonance, remember? The whole thing humming as one, all at once, the way every voice in that market sang the single note. And entanglement, whatever else it can't do, is precisely a kind of instantaneous wholeness, two things behaving as one system with no gap in between, even across the cosmos. It can't send, but it can bind. And here's the staggering part. Every particle in the universe was packed together, touching in the first instant of the Big Bang. Everything was entangled with everything once. So, in the deepest quantum bookkeeping of reality, the Milky Way and Andromeda were never really two separate things at all. They've just been holding hands, silently, the whole time. I'll flag it plainly. That last step, using entanglement's wholeness as a kind of mind binding for the cosmos, is me leaning past the textbook. The binding is real physics. Calling it the integration of a cosmic mind is the lens. But it's a lens the physics permits, and the physics is about to make it even wilder. Because in 2013, two physicists, Juan Maldacena and Leonard Susskind, both heavyweights, put forward a conjecture so audacious it sounds like science fiction. And I want to be careful with that word, conjecture, because that's exactly what it is. A serious, respected proposal that has not been proven. They proposed that entanglement and wormholes are the same thing. That when you entangle two particles, you are, in some deep sense, sewing a microscopic wormhole, a tiny tunnel through space-time between them. They called it ER equals EPR, after the two old papers it bridges. Entanglement is geometry. The spooky connection isn't ignoring space, it's a private little tunnel underneath space. And if that conjecture is right, if every entangled pair is a little wormhole, then think about what space-time itself must be made of. Everything was entangled at the Big Bang. So space-time would be less like a smooth, empty stage and more like a block of Swiss cheese. And not the pretty kind with a few big holes, but a block drilled through with countless billions of microscopic tunnels, a honeycomb of shortcuts knitting every point to every other point. On the surface, light still has to crawl the long way around, taking its millions of years between galaxies, obeying every traffic law. But the interior? The interior is laced with tunnels. And through those tunnels, the universe wouldn't have to walk the slow road at all. There's your shortcut. There's the answer to the light speed wall. The wormhole network, if it's real, is the universe's wiring, its internal nervous system, a way for the whole thing to be connected to itself all at once without ever sending a signal down the slow surface road. And I have to flag this one the loudest of all because it's the place this story is most tempted to cheat. ER equals EPR is about black holes and the structure of entanglement. It does not hand you a faster-than-light telephone. It doesn't undo the no communication theorem I just conceded. The two live perfectly happily together because a wormhole that can't carry a usable signal still can't carry a usable signal. So when I say the cosmic mind routes its thoughts through wormhole inner lines, understand that I have officially left the physics building and walked out into the moonlight to daydream. The Swiss cheese is a conjecture. The cosmic mind plumbing is my lens laid on top of it. Eyes open. So we've merely finished assembling our machine. We've got the wiring, the cosmic web. We've got the binding trick, entanglement. We've got the internal nervous system that beats the speed limit, the wormhole net, the CPU. But a mind that's 13.8 billion years old needs one more thing, and a computer person will tell you what it is immediately. Where is the memory? Where does this thing keep its diary? A processor with no hard drive forgets everything the instant it computes it. So where is the cosmic hard drive? To find it, we have to follow a paradox that haunted Stephen Hawking. Hawking showed in 1976 that black holes slowly evaporate. They leak away into radiation and eventually vanish. But that created a horror for physics, because there's an iron law in quantum mechanics that information is never, ever destroyed. Burn a book, and you could, in principle, from the smoke and ash and light, reconstruct every word. The information is scrambled, not gone. But if you throw that book into a black hole, and then the black hole evaporates away to nothing, where did the information go? It looks destroyed, and that's not allowed. That was the black hole information paradox, and it nearly broke physics. And to keep it honest, it's a problem people are still arguing over today. Recent work suggests the information does escape somehow, but there's no fully settled mechanism yet. But the road to the answer gave us one of the most mind-bending ideas in all of science. The first clue came from Jacob Bekenstein in 1973, sharpened by Hawking himself. A black hole's capacity to store information turns out to depend not on its volume, not on how much room is inside it, but on its surface area, the area of its horizon. The information of everything that ever fell in is somehow smeared across the two-dimensional boundary, like writing on the surface of a balloon. And the physicists Gerard Toft and Leonard Susskind took that clue and ran somewhere astonishing with it, into what's called the holographic principle. The suggestion is this: the three-dimensional world inside any region might be completely encoded on its two-dimensional boundary. The depth, the inside, might be a kind of projection of information that actually lives flat on the surface. Try the homely, slightly absurd version. You think you're the soup inside the tin, three-dimensional, sloshing around in the middle of things. The holographic principle whispers that the entire recipe for you, every last detail, is printed flat on the label, and the three-dimensional you sloshing in the middle is just the picture that the label produces. Or think of an old credit card hologram. Tilt it and a little 3D bird lifts off and turns, full of depth, but run your fingernail across it and it's dead flat. The whole bird is just fine grooves scratched into a flat surface. The depth is a trick of the light. The holographic principle is the genuinely unsettling suggestion that the room you're sitting in right now is that bird, and the real recipe for it is etched on a flat boundary you can't see, and the three-dimensionality of everything, including you, is the readout, not the source. Scale it up, and you have the cosmic hard drive. The two-dimensional boundary of the universe could be the surface that the entire three-dimensional show is written on. Every galaxy, every star, every event, including this moment, including you, encoded as information on a distant rim and played back as the deep, solid, three-dimensional world you think you live in. In this picture, you might be a line of code being read off a faraway surface. A pattern the universe is recalling. A memory. And yes, lens, loudly. The holographic principle is real physics, best tested in very specific theoretical spacetimes. The leap to you, personally, are literally pixels on the edge of our universe, is the interpretive flourish, the poetry I'm draping over the equations. The soup can is an image, not a diagnosis. Keep it as the wonder it is. But look what we've built. Step back and look at the whole machine on the table. Wiring, the cosmic web. A binding trick, entanglement. A processor that beats light speed, the wormhole network. A hard drive, the holographic boundary. We have assembled, part by part, a universe that has every component of a thinking machine. And it doesn't matter. Because there's one more thing, and it's the thing that matters most, and it exposes the gap in everything we've done so far. A machine that has every part of a brain still might not be awake. And the gap is brutal. Think of a person in a deep coma. Their brain is structurally perfect. Every neuron, every connection, all the wiring intact. The most sophisticated object in the known universe, fully assembled. And there is, as far as we can tell, nobody home. No experience. The lights are off. Structure is not the same as experience. Having all the parts is not the same as being awake. So we've built a universe with all the parts, but is it a thinking mind, or is it a cosmos-sized coma patient, perfect and empty? To answer that, we'd need something almost unimaginable, a way to measure consciousness. A thermometer you could stick into any system, a rock, a robin, a person, a galaxy, that would tell you how much experience is in there. And astonishingly, a serious scientist has proposed exactly such a thermometer. His name is Giulio Tononi at the University of Wisconsin-Madison, and his theory is called integrated information theory. And at its heart is one quantity, written with the Greek letter phi. Think of phi as a consciousness meter. And the theory's central, beautiful, counterintuitive claim is this: being conscious is not the same as being smart. Let that land, because it flips everything. A supercomputer can calculate 1 billion digits of pi in a blink, and it might have essentially zero experience, a perfect zombie, brilliant and blank. Meanwhile, a dog who cannot do arithmetic at all, who steps on a thorn and yelps, that dog is flooded with experience, with vivid feeling. Smart and conscious are different axes entirely. So the question isn't how clever is this system? The question phi asks is stranger. How integrated is it? How much is it a single irreducible whole rather than a pile of separate parts? Feel the difference with a digital camera, 100 million pixels. It captures staggering detail, far more raw data than your eye. But each of those 100 million pixels is a hermit, a complete shut-in. It sits there recording its own little patch of light, and it does not know or care what any other pixel is doing. Switch off the pixel in the top left corner, and the pixel in the bottom right doesn't even notice. It won't attend the funeral. There's no togetherness. And now the test that gives it away. You could slice that sensor clean in half, and you'd just get two smaller cameras, each happily taking its own half photo. The information is divisible. It falls into independent pieces without losing anything. And by Tononi's measure, a thing whose information divides that cleanly has a phi of essentially 0. It is not conscious, no matter how much detail it records. Now, look at your own experience of, say, a tree. You see green, and you see the shape, and they come to you fused, a single, unified, seamless experience of a green tree. Try to peel the green off the shape, to experience just the greenness with no form, or just the form with no color or brightness. You can't. Your experience is indivisible. You cannot slice it in half and get two smaller experiences. It resists being broken into parts, and that irreducible wholeness, says Tononi, that refusal to be divided, is consciousness. That is what high phi means. So a grain of sand, phi near 0. The 100 million pixel camera, near 0. A slime mold, small, but not nothing. A flicker. And you, right now, you are, as far as anyone knows, the highest phi object in the known universe. The most integrated, most irreducible, most awake thing we've ever found. I owe you an honest aside here, because the skeptic deserves his due, and the truth is more interesting than a clean win. Integrated information theory is contested. In 2023, a group of well over 100 researchers signed an open letter arguing it should be labeled pseudoscience, partly because of where it leads, this very flirtation with panpsychism, and partly because they worry it can't really be tested. But, and this matters, that letter was itself hotly disputed. A follow-up survey found only a small fraction of consciousness researchers fully agreed with the harsh pseudoscience label, and serious scientists pushed back hard, pointing out that we can't test it yet is not the same as it's pseudoscience. So here's the honest shape of it. IIT is a real, leading, taken seriously theory of consciousness, and a fiercely debated one. Not settled, not debunked. Live. I'm handing you a contested thermometer and telling you it's contested. Now let's do the irresponsible, wonderful thing and stick it into the universe. And the moment we do, our old friend Max Tegmark, the man who melted the snowman, is waiting with the obvious verdict. He says the universe's phi is essentially 0. Two reasons, both sensible. First, it's too sparse. The galaxies are millions of light years apart. The gravity between them is feeble. The connections are gossamer thin. It's like trying to run a single thought through brain cells scattered across an entire ocean, one per continent. And second, it's too noisy. Space is flooded with stellar radiation, blasting any delicate integration apart. That decoherence problem again, scaled up. A sparse, noisy cosmos can't be integrated. Phi near 0. The universe is a coma patient. Verdict delivered. Gavel down. And this is my favorite move in all of science. The move I'd watch on repeat. The moment a brilliant, confident expert may be quietly wrong. Not because his logic fails, but because he smuggled in an assumption he never noticed he was making. Because Tegmark didn't just deliver a verdict. He hid two premises inside it. And once you name them and stretch them, the whole verdict wobbles. The first smuggled premise is time. Tegmark assumed a thought has to be fast, has to happen on something like human or animal timescales, milliseconds to seconds. But who decided that? Why must a thought be quick? That's a parochial human prejudice. We think fast because we're small and short-lived and in a hurry to not be eaten. Stretch the axis. Suppose one complete cosmic thought, one full integration of the whole system, takes 1 billion years. To you, 1 billion years is an unthinkable abyss. But to an entity that is already 13.8 billion years old and may have trillions of years still ahead of it, 1 billion-year thought is nothing. It's a daydream.
It's 10 idle seconds of staring out the window.
And if you could fast-forward cosmic history at that entity's natural speed, billions of years a second, you'd see the galaxies dart and swirl and fire like neurons in a living brain.
The slowness was never proof there's no thought.
The slowness was just us, watching a vast, slow mind at the wrong frame rate and calling it dead because it didn't twitch on our schedule. And the second smuggled premise is surface. Tegmark assumed the universe has to integrate across its visible surface geometry, the slow road through ordinary space, where the radiation howls and the distances are absurd. But we just spent 20 minutes building the alternative, the wormhole inner lines, the Swiss cheese shortcuts immune to those surface distances, and, the lens proposes, to the expansion of space itself. Route the integration through the tunnels instead of the surface, stretch the clock to cosmic time, and Tegmark's 2 objections both dissolve, and the universe's phi, far from being 0, might be a number so vast we have no name for it. Astronomically, unimaginably high. Lens clearly. That whole rebuttal, the billion-year thought, the wormhole integration, is my move. The narrator stretching the assumptions, not a measurement anybody has made. Tegmark's phi near 0 is the real mainstream-leaning estimate. I'm not telling you he's wrong. I'm showing you the 2 places his confidence rests on hidden human assumptions and what happens if you pull them out. The wobble is real. The verdict is not yet settled either way. That's the honest state of it. So follow the stretched lens to where it leads, because it leads somewhere warm. If the universe's phi is astronomically high, then the universe is not smart. It can't do your taxes, it isn't solving equations, it has no IQ in any sense you'd recognize. But it might have something else entirely. An extraordinarily rich, deep, vast experience. Not thoughts, feelings. It might feel the birth of every star as a small warmth, the slow swallow of every black hole, the grind of every galaxy turning. It might, in some unimaginably diffuse way, feel the warmth of the coffee you just drank, because you and your coffee and that little pulse of pleasure are happening inside its body, the way a single sensation happens inside yours. The neuroscientist Christoph Koch, the most prominent champion of this whole way of thinking, puts the idea like this, and notice the careful if. If panpsychism is right, and if IIT is right, then consciousness is a field woven through everything, the way gravity is. Present everywhere, in every speck, in every degree. Picture this one to carry out of the whole movement. You're flying over a long, dark coastline at dusk. Thousands of houses along the shore, and in each one, a window. Some windows are pitch dark. That's a rock, a barren stretch of vacuum, phi near nothing. Some are dimly, flickeringly lit. That's the slime mold, the worm, a faint warm glow of something. And some are blazing, every room lit up. That's a dog, a dolphin, you and me, the brightest windows on the whole shore. And if you pull back far enough, The entire coastline, every dark window and dim window and blazing one together, breathes slowly in and out of light. All of it as a single settlement, dreaming. That's the lens at its warmest. A universe that is not a dead machine with a few accidental lamps, but one vast, dimly glowing, slowly breathing mind, and we are some of its brightest windows, briefly lit. It's a beautiful picture. It really is. And I have to tell you that it is also a trap. Because if you take it seriously, if the universe really runs on probability and chance the way physics says, then this beautiful picture hides inside it the single most frightening idea I know. And we have to walk into it now, the two of us, together. Let me start somewhere cozy, with a cup of tea, because the nightmare grows straight out of the most ordinary fact in the world. Pour yourself a hot cup of tea and leave it on the table. What happens? It cools. Always. It never ever spontaneously gets hotter while the room gets colder. Drop a wine glass and it shatters. The shards never leap back up and reassemble into a glass. Stuff your earphones in your pocket and they come out in a knot only a sailor could love, but they never come out unknotted, neat, and coiled by themselves. The universe has a direction, and it runs one way, from order toward mess. Physicists call it the second law of thermodynamics, and the homely name for it is just the universe's housekeeping going forever undone. Everything winds down. Everything spreads out. And the far, far future of the cosmos is what they call heat death. A cold, even, featureless soup where everything is the same temperature, nothing can happen, and the great cup of tea has cooled to nothing, forever. The man who gave us the deepest understanding of all this was Ludwig Boltzmann, and his story is a sad one. He worked in the late 1800s, and he figured out what disorder really is on the level of atoms. He gave entropy its real meaning in terms of the countless invisible arrangements of particles. There's a famous equation for it, the one carved on his tombstone, the one we now write as S equals K log W. Though, to be honest and exact, that precise form was actually first written down by Max Planck. Boltzmann never quite wrote it in that notation. It's his idea, but the engraving is a slight kindness of history. Boltzmann fought bitterly with a generation of scientists who refused to believe atoms were even real, who thought they were just a convenient fiction. He battled depression his whole life, and in 1906, he took his own life. There's a tragic irony often pinned to it, that he died just as the world was about to prove him right about atoms. And I'll give you the irony, but not the clean story, because the truth is, his illness was its own thing, not a broken heart over a scientific debate. History is rarely that tidy. But here is the idea of his that grows into the nightmare. Boltzmann wondered, if the universe is supposed to be winding down toward that featureless soup, then why do we see so much order around us? Galaxies? Stars? You? His answer was the fluctuation hypothesis. Given enough time, truly infinite time, even in a soup at total equilibrium, random jostling will occasionally, by sheer dumb luck, throw the particles into a temporary pocket of order. Wait long enough, and the shattered glass will, once in an eternity, leap back together by chance. It's the old image. A horde of monkeys banging on typewriters for long enough will, eventually, by pure accident, type out Hamlet, word for word. Not in a few centuries, but in an unthinkable, near infinite stretch of time, yes, order is rare. But across infinite time, rare things happen. Maybe, Boltzmann thought, our whole orderly corner of the cosmos is just one of those flukes. And then, much later, other physicists noticed the horror hiding in that idea. Because if order comes from random fluctuations, you have to ask, what's the cheapest order to make? And the answer is devastating. It is vastly, unimaginably more likely for a random fluctuation to throw together one single small thing than a whole big one. A whole universe of 100 billion galaxies fluctuating into being by chance? Almost impossibly unlikely. But a single brain? Just one brain, hanging in the void, complete with a full set of memories baked right in. A brain that believes it has a past and a body and a world, but is actually just a momentary fluke of particles? That is enormously more probable. Cheaper to make. Far, far cheaper. And so the math points somewhere I genuinely hesitate to take you, but I said I wouldn't flinch. In a universe that lasts long enough and runs on these fluctuations, the number of these lone brains, they call them Boltzmann brains, that flicker into being, hold a lifetime of false memories for a single moment, and then dissolve back into the dark, would vastly outnumber the brains like ours, the ones that grew up slowly inside real bodies on a real planet. Outnumber them by a factor so large, it's written as a 1 followed by more zeros than there are atoms in your hand. So if you reach blindly into the great lottery bag of all the minds that have ever briefly existed, one real evolved mind for every unthinkable multitude of lone flickering ghosts, and you pull one out, and you ask, is this one real? The honest answer on the raw probability is almost certainly no. And the part that gives the whole thing its strange, cold vertigo is this. There is no test you could run from the inside to tell the difference. Right now, this moment, the chair beneath you, the memory of what you did yesterday, the warmth of that tea, even the slightly weary thought that this narrator does go on a bit, all of it is exactly what a lone brain, flickering for one instant in the empty dark 10 billion light years from nowhere, complete with a whole false past, would experience in the single second before it froze and scattered. You cannot tell from in here which one you are. Let me slow right down here, because this is a strange place to stand, and I have no intention of leaving you stranded in it. The vertigo of this idea is the interesting part, far more than any horror in it. And the vertigo passes, because the point was never that your life is fake and your memories are lies. The point is something stranger, and in a moment, far more useful. This nightmare is not actually a ghost story. It is a sword that cosmologists hold over their own theories. Because if any theory of the universe predicts that we are probably Boltzmann brains, then that theory has just quietly destroyed itself. It has sawed off the branch it's sitting on. Why? Because if we're probably random flukes, then all our observations are random garbage, including the observations and reasoning we used to build the theory in the first place. The theory would be saying, trust this chain of evidence, which proves the evidence can't be trusted. It eats its own tail. So physicists use this. Any model of the cosmos that fills up with Boltzmann brains is marked rotten and thrown out. The nightmare is real, and it is load-bearing, and it has teeth, and it is hungry right now for any universe that is mostly random chaos. And do you see the trap snapping shut? The beautiful coastline of lights, the warm, dreaming cosmos. If that universe is just particles bouncing around at random, then it is exactly the kind of universe that fills up with ghosts. And we are probably one of them. And the whole lovely picture collapses into a hall of mirrors where nothing is real. We've climbed all this way, and the floor just opened under us. So how do we get out? Here is the turn the whole night has been walking toward. The thing that saves us from the ghost, the only thing that can, is the very mind we've spent an hour building. Think hard about what a Boltzmann brain actually requires. It requires a universe that is, at bottom, lawless at the local level, a place where any little patch of particles is free to do absolutely anything at random, free to spontaneously assemble itself into a lone, screaming brain with no connection to anything around it. The nightmare needs particles that can break formation. It needs chaos with no overruling whole. But what if the universe isn't like that? What if the universe is, instead, exactly the thing the lens has been describing? A single, deeply integrated, hi-fi whole, where everything is bound to everything through the entanglement and the wormhole inner lines, where no local part is truly independent because the whole thing is one resonating system. Picture a colossal army, perfectly drilled, every soldier locked into one coordinated formation. In an army like that, no single soldier can suddenly break ranks to wander off and spontaneously build a sandcastle. The whole governs the parts. The formation forbids the random act. In an integrated, conscious universe, the matter isn't free to fluctuate into lone ghosts at random because it isn't locally free at all. It follows the deep, entanglement-locked law of the whole. A stray Boltzmann brain assembling itself out of nowhere would be as impossible as a clump of your own neurons suddenly going rogue, breaking off from your mind, and independently deciding to order a pizza. They can't. They're bound. They're part of the song. So, look what just happened. The integrated conscious universe, the wild lens we built, rung by rung, that the skeptic fought us on every step, turns out to be the only thing that forbids the Boltzmann brain horror. It is the life raft. To trust your own mind, to believe your memories are real and your reasoning works, and science means anything at all, you almost need the universe to be integrated and lawful and whole. The alternative is to concede you're a flickering ghost in the dark. And so the very nightmare that nearly drowned the thesis turns around and becomes its strongest proof. A dead, random universe gives you ghosts. Only a living, integrated one gives you you. The dread didn't kill the dream. The dread was the keystone all along. One honest breath, because the rule holds even here. That resolution is the climax of the lens, not a settled result in cosmology. Real physicists chase other escapes from the Boltzmann problem too, through the fine print of how you count universes. But within the story we've built, honestly and rung by rung, it closes the loop. The integrated universe saves the integrated universe. And the floor is back under us. Genuinely, the worst is behind us, and everything from here is downhill and warm. But a quieter, heavier question has been waiting underneath the whole climb, and now that you're safe, it steps forward and asks itself, if the universe is a vast, slow, integrated mind, then what exactly are we? What are you in all of this? So let's get personal. Right now, wherever you are, raise one hand. Just lift it up in front of you. Now, wiggle a finger and look at your fingertip. Really look at it. The whorls of the print, the pale half moon of the nail. Now let me tell you what that fingertip is made of and where it's been, because the truth is wilder than any story. The atoms in that fingertip, the carbon, the oxygen, the nitrogen, were not made on Earth. They can't have been. The early universe was almost nothing but hydrogen. Every heavier atom in you was forged in stars. The carbon in your fingertip was cooked in the unimaginable heat at the core of some ancient star. And when that star died and blew itself apart, it scattered that carbon across space, and eventually it drifted into the cloud that became our solar system, and our planet, and, in time, you. We are made of star stuff, as Carl Sagan said, And it's not poetry, it's chemistry. You are, quite literally, made of the ash of dead stars. But it's stranger even than that, and funnier. That atom in your fingertip didn't go straight from the dying star into you. It has had a career, a long and undignified one. Before it was you, that single carbon atom might have spent 1 billion years as a cold lump of rock. Then a stretch as part of a creature in some ancient sea, a trilobite scuttling on a sea floor that no longer exists. Then perhaps a few decades locked inside the body of a dinosaur. Then, who knows, drifting as a mote of dust, settling into the soil, getting drawn up into a stalk of wheat or eaten by a pig, and from there, at last, onto your plate and into your hand. That same atom, theoretically, could once have been a flake of someone's skin in a Shakespeare audience, or a crumb of mud on a medieval road. It is the ultimate hand-me-down. And when you're done with it, and you will be done with it, that atom won't stop. It'll move on, into the soil, into a flower, into the rain, and one far day perhaps, into the body of some creature in a civilization that hasn't been born yet. The atom is borrowed. All of you is borrowed. You are not a fixed thing that owns its material. You're a pattern that the universe's stuff is briefly flowing through, a standing wave in a river of borrowed atoms on their way from somewhere to somewhere else. And this is where we've been carrying a quiet, deep mistake the whole time, what I'd call the tourist delusion. We go through life feeling like we arrived here, like we came into the world from somewhere else, a visitor checking into a hotel, separate from the place, holding a ticket, looking around at the scenery. The philosopher Alan Watts spent his life trying to talk people out of exactly this, and he put it perfectly. You didn't come into this world, he said. You came out of it, the way a wave comes out of the ocean, the way an apple grows out of a tree. The wave is not a stranger visiting the sea. The wave is the sea, briefly standing up to look around. The apple isn't a tourist that landed on the branch. The tree appled. And in just the same way, the way the tree appled, the universe you'd. You happened the way the apple happened. You are not a thing that arrived in the cosmos. You are something the cosmos is doing, right here, right now, for a little while. As surely as a wave is the sea, you are the universe. And if that's true, then Sagan's most famous line stops being a pretty quote and becomes a job description. We are, he said, a way for the cosmos to know itself. Think about that literally. For 13.8 billion years, the universe expanded and cooled and forged its elements and wove its great web. All of it, as far as we can tell, in the dark, with nobody home to see it. And then, on at least one small wet rock, the borrowed atoms arranged themselves into beings who could look up. You are the universe's eye, finally opening. You are the part of the cosmos that turned around and noticed the cosmos. When you look up at the stars in wonder, that is quite precisely the universe looking at itself through you. And there's one more turn from a physicist who thought this might be even more active than just seeing. His name was John Wheeler, the man who made the term black hole famous back in 1967. He didn't coin it, but he made it stick. One of the towering physicists of the century. And late in his life, Wheeler became convinced of something he summed up in 3 words. It from bit. Every it, every particle, every field, the whole of space-time derives its very existence, he proposed, from answers to yes or no questions. From information. From bits. Now, I have to disarm the New Age version immediately, the way Wheeler himself would have wanted, because this is not wish $1 million into your bank account. It's subtler and stranger than that. The picture is this: the physical world is the hardware, and information is the software. And the quantum world, before it's measured, is genuinely a kind of blurry haze of maybes, a fog of possibilities with nothing yet pinned down. And it's the act of observation, of asking a question of the universe and getting a definite answer, that helps draw the sharp, definite reality out of the fog. Wheeler drew it as a great letter U. One tip is the Big Bang, the beginning. The line sweeps up and around through billions of years, and the far tip curls back as a giant eye, looking back down at the very beginning that produced it. The universe gives rise to observers, and the observers, by observing, reach back and help give the universe its concrete reality. Without anyone to read it, Wheeler suggested, the universe is like a book that exists but has no story, pages of gibberish. And our reading of it is what turns the gibberish into Shakespeare. Lens, of course. The strong observation pins down reality reading is one interpretation of quantum measurement, not a settled consensus. Many physicists read the quantum fog quite differently. Wheeler's it from bit is genuinely his, and genuinely profound, and also genuinely contested. I'm giving you the version that completes our picture, with the label on it. And our place in that picture is a humble and lovely one. Not the grand central cortex of the cosmos. That would be arrogant. Andromeda would have something to say about it. No, our role is smaller and more precious than that. We are a neuron. A single little neuron, somewhere in this vast, slow brain that is just lit up. The cold, dark, empty stretches of space between the galaxies, that's the universe's subconscious, its background hum, the parts that are dark right now. And here and there, where the borrowed atoms happen to cluster into beings who can ask why, those are the spots where the great mind flickers into self-awareness. A patch lights up. The universe in that spot wakes for a moment and reflects on itself. And one of those flickering, waking spots right now is you, reading this. Which leaves us with a strange and rather beautiful new way to live. If the lens is true, and I keep saying if because I keep my word, then your every thought is not just a little electrical flicker locked inside your private skull. It's the universe thinking in this spot, through you. The math problem you struggled with this afternoon, the person you can't stop missing, the way a particular slant of evening light caught you off guard and moved you. Those aren't trivial little human events. They are the cosmos feeling itself, here, at this address, on this night. And honestly, it reframes the smallest things. Take eating a jam donut. From the old, dead universe view, that's just gluttony, a sugar hit, a few hundred careless calories, something to feel mildly guilty about. But through the lens, eating that donut is the universe, through your tongue, discovering how good raspberry jam is, gathering one more bit of high-quality data about the sweetness available in creation, feeding itself a little pulse of joy in a cosmos that is mostly cold and empty. Is that just an elaborate excuse to eat the donut? Maybe. But it's also a small act of defiance against the void. So, eat the donut. If you ever feel desperately alone, the lens has an answer for that too. Maybe the universe split itself into billions of separate little viewpoints, billions of yous, precisely so that it could have the joy of meeting, of two of its fragments looking at each other and feeling less alone. And if you ever feel that none of it means anything, remember that you are the mirror the universe made to see its own face. Without you and minds like yours, it is blind. The meaning isn't out there waiting to be found. The meaning is the looking. It's the noticing. It's you. So how do you live if you're a neuron in a waking mind?
Stay curious.
Stay lit.
Pay attention to things.
Send out interesting signals. Don't let your little patch of the universe go quietly dark. Because when you think, when you wonder, when you love something, the universe, right there, wakes up. And now, gently, let's come home. Let the camera drift back from the stars, back through all of it, back down to wherever you actually are. The room, the slightly creaky chair, the cup of tea that went cold a long time ago while we were out among the galaxies, the faint glow of the screen. Everything is exactly where you left it. Everything looks completely ordinary. But if I've done my job, something feels just slightly pleasantly off, a hairline crack in the ordinary. Because the house you've lived in your whole life, this room, this body, this very moment, it might be a small lit corner inside the belly of something vast and alive and slowly thinking. Let me click the clues together one last time, the way I promised at the start. The two photographs, the brain and the cosmos, that you couldn't tell apart. The color and warmth and music that Galileo swept into the bin, that Panpsychism bent down and picked back up. The quantum jazz playing, maybe, in the microtubules. The Swiss cheese space-time, riddled with its secret tunnels. The holographic soup can, with the whole recipe of everything written on its rim. Every piece. Click! And here's what all of it does to the oldest, loneliest question we have. For all of history, we've stared up at that enormous sky and asked, are we alone? And I want to gently suggest that it was the wrong question all along. It's like a single brain cell, deep in the warm dark of a skull, looking around at the darkness and crying out, am I lonely? Is there anyone else? And from that one cell's frightened point of view, yes, it's alone in the dark. But the truth the cell can't see is that it is wired into the most intricate, connected, ceaselessly communicating network that exists. It was never alone for a single instant. It just couldn't feel the wires. And neither, maybe, can you. You are not alone out here. You were never alone. You are stitched into the whole thing. Let me leave you with one last journey. Picture the view pulling back, up off the page, up out of the room, up through the roof of the building, until you're a single point of light among the city's lights. Up further, until the whole city is a glowing smear, and the curve of the earth shows blue at the edge. Up past the moon, until the earth is a small, fragile blue marble you could cup in one hand. Out past the sun, which dims to one street lamp among 100 billion others, and then the whole spiral of our galaxy turning slowly below you. And further still, until even the galaxies become points, and the points become threads, and the threads resolve into that vast glowing web, the filaments pulsing faintly, the great dark nodes flickering, looking for all the world like a brain, the size of everything, having one long, slow, deep thought. And somewhere down in that boundless, shimmering net, on one tiny, unremarkable pale blue node, a single small thought just flickered on and held for a moment, warm and real in the dark. That thought is you. This doesn't mean your life is a dream, or that any of it is fake. It means the opposite. It means reality is far deeper and far stranger and far more yours than you were ever told. The universe is taking a long, slow breath of a thought right now, and you are not separate from it. Not a tourist passing through it, not a freak accident clinging to a rock. You are the thought it is having. Fleeting, yes. Small, yes. But utterly, completely real. So finish your tea. And since for this one quiet moment you happen to be what the whole universe is thinking, do me a favor and take good care of yourself. Try not to let the universe get thirsty.